So welcome back students. We are going to discuss the continuation part of the Centroid that we have taken in the class. So the second question you can see to find the centroid of the shaded portion, that is there is a triangle here, a rectangle portion, from that a semicircular portion is cut. We are supposed to find the centroid of this particular shaded area. So starting with the first, if we follow certain steps, it will be easy for you. So we will divide this into three portions. That is, the first portion we are having a triangle. The second portion we will have a rectangle having total dimension of 200 by 150. From that, if we deduct this semicircular area, that is figure 3, we will get this shaded portion. So we will divide this into three regular figures whose centroid is known to you. From there we will start this numerical. Okay, that is, first one, we have the area A1. So in order to find the area A1, we have considered the reference axis as this is my x-axis and this is my y-axis. I told you this reference axis is very much important when you consider this centroidal distances. So I will fix the reference axis first in this way. That is, we have the reference axis in this form. That is, my reference axis y is here and my reference axis x is here. So with respect to that, I will be finding all my values. The first one is the right triangle triangular area having area, that is half BH, half into 100 into, we have 150. You will get this value nearly 7500 mm square. You will get this value as 7500 mm square. And x1 is the distance from the y-axis to the centroidal distance of this rectangle triangle. So y1 is the distance from here, this y-axis, to here. So I know the centroid is somewhere here. So x1 is this distance. So I'll get this y1 distance as this one and x1 distance as this one. That is, I can take the x1 as what, 2 by 3 of 100. That is, x1 is what, 2 by 3 of 100. That is, from the y-axis it is at a distance of 2 by 3 of 100. I'll get it as 66.67 mm. And y1 is also at a distance of 2 by 3 of 150. That is, I'll get it as 100 mm. That is 2 by 3 of 150. That is, I'll get it as 100 mm, because it is the orientation of this right angle triangle is this way. So if I take the distance of its centroid from this, it is 2 by 3, because we have studied general case this is 1 by 3, so the remaining part is 2 by 3. So I can summarize it as A1 is equal to this much. Similarly, the second figure, if I am taking, that is the rectangular figure as a whole, then it is having the centroid somewhere here. Its centroid is somewhere here. So if I note it properly, your y2 is at a distance of 150 by 2 and your x2 is at a distance of, I am considering my axis here. So my centroid distance is actually at a total distance of, starting from here, it has to move from here up to here, which means the total distance is this 100 plus 200 by 2. That is 100 plus 100. That is, you considering your reference axis, your centroid distance is this much far. So we have to consider that. That is, the total centroid distance is from here up to here. That is 100 plus 200 by 2. That is b by 2. 200 by 2. You'll get it as 200 mm. So the first one is the centroid distance. So here you have considered the second figure. The area of this is what? This is 200 and this is 150. That is 200 into 150. B into D, you will get this value as 30,000 mm square. Similarly, x2 you will get it as what? 100 plus 200 by 2, that is 200, and y2 you will get it as, y2 is common, that is h by 2, that is 150 by 2, you will get it as 75 mm. So that is the second one. Now when you consider the third one, that is your third figure, that is your semicircular portion. this semicircular portion has to be deducted from this rectangular portion. So I need to find the area of the semicircle. That is, I can find the area as what? That is pi d square by 4 divided by 2. I will get it as pi d square by 4 is the area of a circle divided by 2, that is into 1 by 2. I'll get it as 3927 mm square. Here the diameter of this section is 50 plus 50, that is 100. So I'll get it as 3927 mm square, and x3 is the distance of the centroidal axis. So if I mark the centroidal axis here, it is somewhere here. It is somewhere here. So the total distance is from here to here. From this portion to this portion it is 100, then another 50 plus 100 by 2, because this is a symmetrical section, so centroid will be exactly here, that is 100 by 2. So the total distance is 150 plus 50, that is, you will get it as 150 plus 50, that is 200. 150 plus 100 by 2, that is 200 mm. And y3 I can mark it as this much distance, that is 4r by 3 pi. That is, I can write it as this is 4r by 3 pi, and you will get this value as 21.22 mm. 21.22 mm, which means I got the value for a1, a2, a3 and x1, x2, x3, y1, y2 and y3. So moving on to this, I'll consolidate this. I know your x bar is equal to what? X bar is equal to a1 x1 plus a2 x2 minus a3 x3 divided by a1 plus a2 plus minus a3, because from these two figures we need to deduct from the first and the second figure. We are supposed to, from the first and second figure as a whole, we are supposed to deduct this semicircular area. So that has to be deducted in the case of your centroid also. So which means I'll get this, substituting these values, I'll get the value for your centroid as x bar distance as 170.21 mm. Similarly y1 also, substituting this, that is y bar is equal to a1 y1 plus a2 y2 minus a3 y3 divided by a1 plus a2 minus a3. Will get this y bar distance as 86.80. that is, if I mark the x bar and y bar distance, I will be getting as 170.21 from this y-axis considered, and 86.81 from this x-axis considered. This is all the considered axis. I can consider the axis anyway, it's up to me, but I have considered this way. So the central distance is 170.21 mm from this, that is your y bar, x bar, and 86.88 as your y bar. I hope you have understood this. Similarly, we will move on to another question, that is, locate the centroid of this shaded portion here. Here the shaded portion is actually, there is a quadrant of a circle. You can see there is a quadrant of a circle like this. There is a quadrant of a circle having 9 cm radius, and there is another quadrant circle here. So what we can do here is, we will consider this rectangle. From that, if we deduct this quadrant of a circle, we will get this shaded portion, and we need to add this quadrant of a circle here. So we have how many figures we have? We have one whole rectangle. From that, one quadrant of a circle is deducted. Second figure. The third one is one quadrant of a circle. So there are 3 figures. We need to divide this into 3 figures. That is 1, 2 and 3. So we will start with this one. That is, we need to find the area of the first figure. Area of the first figure, if you need to find out, that is, you have area, we have considered this as a rectangle. This is a rectangle having 9 cm by 9 cm. So the area is what? 9 into 9, that is 81 cm square. Now the x1 distance is it is at this distance 9 by 2, that is, you will get it as 4.5 cm, and y1 distance is also 9 by 2, that is, I will get it as 4.5 centimeters. Similarly, I can find the value for a2. a2, I have considered the semicircular portion, that is pi d square by 4 into 1 by 4, that is 0.25 times pi d square by 4. I'll get this one as, this d is what? D is actually 9 plus 9, that is 18. Here this is given radius, so I'll get this value as 63, I'll get this value as 63.62 centimeters square. Now the centroidal distance is actually x2, that is 9 plus 4r by 3 pi, that is you'll get 9 plus 4r by 3 pi, you'll get this distance as 12.82 centimeter, and y2 is simply 4r by 3 pi, that is you'll get it as 4r by 3 pi. Substituting this value for r, you'll get it as 3.82 centimeters. Now A3 is the third quadrant we need to detect. So A3's area is similar because it's the same radius, that is pi d square by 4 into 1 by 4. You will get it as 63.62 centimeters square. Now x2 is at a distance straight away from the axis, that is 4r by 3 pi. You will get it as 3.82 centimeters, and y3 is what? Y3 is actually, it is inclined, so this distance is what? This distance is 4r by 3 pi. So from the axis I need to get, so this distance is what? R minus 4r by 3 pi. This distance is r minus 4r by 3 pi, so that I'll get this distance as r minus 4r by 3 pi, that is 5.18 centimeters. So these three are now known to you. From there you'll get the value for your x bar similar to the previous question, that is you'll get this one as 11.57, and y bar you'll get it as 3.43. so that is 11.57 and 3.43. Now one more typical kind of question we'll discuss, that is question number 3. Here the centroid of the shaded portion is asked, but the general equation of the curve is given, that is here there is a line having general equation y is equal to x and another parabola given as y is equal to x square by 2. You are supposed to find the centroid of this particular shaded portion. So what we can do here is we need to go to the basics of your centroidal findings, that is to find x bar similar to what we had done, we need to consider a small distance dx which is moving from 0 to, here the x coordinate is what? 4. So you need to have a strip which is moving from 0 to 4 having this small width dx. The height of this is h, so the general equation for h the general equation for area I can consider. We are considering as vertical strip of thickness dx. So area of the strip dA is this dA, I can take it as what? I can take this dA as h, height into width, that is dx. This height I can mark is the difference between these two lines, that is 2x minus, that is y here 2x minus the y ordinate of this, that is x square by 2 into dx, that is will give you the area. So marking this, I know x bar is equal to integral x dA divided by integral dA. dA value we had got it as h dx, that is 2x minus x squared by 2 dx, and this small strip has to move from 0 to 4. So integrating between the limits 0 to 4, I'll get the value for your x bar. Applying the integrate, I'll get this as x bar as 2. Similarly in order to find y bar, I need to consider a strip having thickness dy which is moving from 0 to 8. It is moving from 0 to 8 like this. So that is moving from 0 to 8 like this. So y bar I have integral y dA divided by integral dA. Here dA will change because dA will be what? dA will be this distance, that is you need to find in terms of x is equal to y by 2, and here x is equal to root of y by 2. So you need to get the value for x in terms of this. So dA can be substituted, and this dA limit is from 0 to 8. You will get the value for your y as 3.2. So altogether I can mark the central distance x bar as 2 and y bar as 3.2. So this is a general case. So if any kind of curve is given, you are supposed to find the centroid, and I hope you have understood these 3 questions. Thank you.